Hello, everyone. You are welcome to lesson 3 of what's the topic variation on the topic variation. Okay, in lesson 2, we looked at the joint variation and partial variation. Okay, in lesson 3, we are going to continue with the partial variation. Okay, so we are bringing the curtains down on partial variation. And if time allows, we'll look at what solution to some selected past questions or likely exams question. Okay, so quickly, let's look at what we have here. We realized that in our previous meeting, we said for partial variation, we'll be looking at the sum. Okay, so you get at least, okay, 2 terms, at least 2 terms. Okay, so quickly, let's look at this question. We know all the tricks. So as I walk you through, I'll once again reiterate those tricks. Okay, all right. So we are told the cost C. Okay, so your cost, you know, you are dealing with one variable or one letter of manning a household is partly constant. Okay, so we know. And partly varies. So we've seen the keywords there, partly. So we should know that we are dealing with partial variation. As the number of people N. Okay, so we know the relation between N and what? And C. Okay, these are the letters or the variables under consideration now. For 8 people, so you've been given your N, the cost is in the C. And for N, 10 people, okay, the cost is C, is this. Find I, an expression for C in terms of N. And you can see that C is capital, N is small. So when you are equally, okay, doing your presentation, go for the exact letters, the way they came. Okay, then I, the weekly cost for 12 watts people. Weekly cost for 12 watts people. Okay, so quickly, let's go and have a look at what the solution to this particular, okay, question. So as usual, if for nothing at all, we know that we write solution, then we write question number 2. We number our solution as well. Now we extract the relation in terms of variation. So we are told, so given that, okay, a certain variable C, which is the cost, okay, it varies partly as a constant. So look at this. And here, the reason why I'm going to write small c. So you can see the distinction here. And remember, I told you, even with the partial variation, you can start with the relation straight away. Okay, but I'm writing this just for us to relate, okay, with it better. But you can always keep the whatever I'm writing here and move to the relation. And this one is specifically for partial variation. But the rest, please go through the variation statement before the relation. So partly constant, okay, and partly varies as the number of n. So that will give us plus what? N. All correct. Okay, so here there will be no conflict. If, okay, this came in small c, I will advise that your constant that you introduce here, okay, you introduce that as a big C. So always distinguish between them. Okay, they shouldn't be the same to avoid conflict. Is that clear? Write in such a way that they will look different. Okay, so now I'll come and write. This implies that, okay, which I said you could have been the implication, what you are going to write here could have been up here. So your C will be equal to, we know we'll get a K times the C, which will give us what? K sub 1. Then this will give us a K times the N. Okay, and that will give you K sub 2N. Another K. But remember, we have 2 K. So I'll write K sub 1, comma, K sub 2, okay, which will be equal to constants. Okay, I told you not to write constant of variation because one of them is not, okay, a constant of variation. The K2 is a constant of variation, but the K1 is not strictly a constant of variation. Okay, so you just write constants. Okay, all right, so now what do? We are going to, okay, we can see a relation in C, but we need to get the K1 and K2 before we can get the C in terms of only N. Now C is in terms of N, K sub 1 and K sub 2. Am I right? Okay, so yes. as always, we need to go and, okay, generate 2 equations like we realized in our previous meeting, okay, to solve for K sub 1 and K sub 2. So the first equation will use the first information here. So if, Okay, 8 people, it means n, is that not it? The n is for the people, is that clear? So if n is equal to 8, our C, capital C, is equal to was 70,000 Ghana cedis. You can ignore the units, okay, for now, unless maybe you are finding, but when you are going to use it, ignore the unit. So I'm going to write, this implies that my capital C, which is 70,000, okay, will be equal to my small k sub 1, okay, plus my small k sub 2 times what? My n, and n is what? 8. Okay, so if you are matured, we could have written 8, okay, k sub 2 straight away. So I'm going to write, this implies that I want to write the variable terms here, but it doesn't really matter. Let's keep it here so that we know that we can equally do same. What is important is make sure your variables are on one side and your constants on the other side. Okay, so now I'm going to keep this. So this will give me 70,000 is equal to what? K sub 1 plus what? 8 K sub 2. So this becomes my equation 1. All correct. Okay, and again, if n is equal to, what is our second n? 10. Okay, your C, capital C, take note, will be equal to 90, okay, 1,000. Okay, so this implies that we are going to get 90,000. We are substituting that into this relation. 90,000, okay, is equal to K sub 1. Now I'm handling this one maturedly plus. I will substitute the n, okay, here. So the n is 10. So that will give us 10 was K sub 2. All correct. Okay. All right. Alma, it's intentional. Okay. So don't worry, it's intentional. But it's good you've drawn my attention to that anyway. Okay, I want to say something because of what I realized in your other submission. So this will be K sub what? 2. So this becomes equation 2. Okay, so now we are going to solve equations 1 and 2 simultaneously. So like I said, anytime you are solving equations simultaneously, listen to the equation. They will tell you the appropriate method to use, be it elimination, substitution. Okay, so now let's see. Okay, elimination will be better because I can easily eliminate K sub 1 because the coefficients are the same, even neglecting the signs. Okay, so on that note, I am going to eliminate K sub 1. So if I want to eliminate K sub 1, then it means my result will be in K sub 2. So, if you look at the sign here, okay, they are the same. So you subtract to eliminate. So in subtracting, you can subtract 1 from 2 or 2 from 1. But like I've told you, okay, because you want your result in K, okay, look at what the two equations. The one with the biggest K sub 210 and the K sub 210, the biggest one is in 2. So it means I'll subtract 1 from 2. So I'm going to do equation 2 minus equation 1. Okay, you can do 1 minus 2, only that you will deal with negative. I want to avoid negative. So that will give me, okay, 90,000 minus 70,000. That will give us what? 20,000, am I right?
Yes.
Okay, it's equal to, it will be K sub 1 minus K sub 1. That will go. That was your intention anyway. So you've eliminated K sub 1. Then take 10 K sub 2 minus 8 K sub 2, and that will give us 2 K sub 2. All correct. Okay, you write it again before you divide. However, in writing it again, I'll write my term in K first. So 2 K sub 2, okay, is equal to 20,000. Okay, over 2 over 2. So I will get what? K sub 2 to be equal to what? 10,000. Am I right? Okay, I will need K sub 2, okay, to find K sub 1. So I will label this as equation 3. Okay, and I either substitute this one into equation 2 or equation 1. But if you look at the two, equation 1 will be better because it involves smaller values. Otherwise, you can use equation 2. So I'll write equation 3 into, and once again, I'm reiterating the point. Don't write put, don't write putting, don't write substitute, substituting. Just write this. equation 3 into, we will know that you are substituting equation 3 into equation 1. And this will always be too short, okay, to take that line. So come and write comma and do your substitution there, or semicolon, or colon if you like. But I usually prefer comma. So now we are going to get, wherever I see, okay, k sub 2 in equation 1, I substitute what? 10,000 there. So that will give me 70,000. Okay, is equal to k sub 1. Okay, then plus, okay, 8 times what? 10,000. All correct. Okay,
Yes,
which
please.
in effect will give us, this implies that 70,000, and you can see that as I move from one line to the next line, row goes to the margin, as I have been doing. Then will be equal to k sub 1. Okay, then plus 80,000. Okay, so on that note, we are going to get k sub 1 to be equal to 70,000 minus 80,000, which will give us minus 10,000. Am I right? Okay, so now that we know k sub 1 and k sub 2, we can comfortably draw our conclusion for, okay, what do you call it? The C in terms of n. So I'll write therefore, okay, my C will be equal to, I come and substitute that one here. K sub 1 is minus, okay, this. But remember, I've told you in every expression, if you have a positive term and a negative term, which one do you write first? The positive. Okay, so now realizing that if I substitute, this term will be negative. However, this will be positive. I'll write that positive term first. So that will give me my k sub 2. K sub 2 is what do you call it? K sub 2 gave us 10,000. So I'll get 10,000 n. Okay, then minus, okay, 10,000. Am I right? Is my point well made, my professors?
Yes, please.
Yes, please.
Okay,
Yes,
then you
please.
move on to what? II. But immediately you move on to II, you should ask yourself, sometimes, okay, you always have a second chance. You ask yourself, do I have I? Have I numbered my way I? And, okay, obviously the answer is what? Is no. So you go and put your I where it's supposed to be. And you know your I is supposed to be here. Is my point well made? Hello, is my point well made?
Yes,
Yes,
please.
Okay,
yes,
great.
sir.
Okay. Okay, so Blaze, Prof. Blaze. Prof. Blaze, can you hear me? Okay, so now let's move on. When she comes on board, we will, she can ask a question. So now let's look
Mr.
at what,
Hackman,
yes, please.
please, the relation we had. Yes, please.
Go ahead. The relation we had has done what?
Please, I was saying that the relation in the second step, the K sub 1 plus K sub 2n. So please, I thought the n would rather be at where the negative 10,000 is because it's K sub 2n.
K sub 2n. Okay, so let me see. So you are thinking maybe we did the wrong substitution. So let me check. K sub 1. Okay, it's supposed to be, you can see that I said one
Okay,
will be
so I've seen
negative.
what you've done.
One will be
You brought
negative,
the
one will be positive.
positive to
Other than that,
the
if you write it that way, you
left
have one
side.
more
I
step. You
didn't
get
get
it? So it's good. If you come and substitute directly, you have one more step for your conclusion, which will mean write the positive first, followed by the negative. But we thought before writing, so that step
So
catered
I've
for.
seen what you've done. You brought the positive.
Okay, so that's okay. All right. Okay, so if you get it, that's okay. So now let's look at, okay, the second part of the question. Okay. Blaze, you can mute. Okay, you let me mute here. Okay. All right. So now what are we supposed to do? Okay, now we can see that we've labeled,
Yes,
okay,
please.
all that we have there. Okay. So now please guide me as to what we are supposed to do. Okay, we said the weekly cost for 12 people. I'm waiting. How do you deal with what's the II? What information is given there? N, is that not it? Are you sure it's N? So we are going to get, okay, if N is equal to, okay, 12. Okay, we need to get the C. Okay, so I'll write there for C will be equal to, so I'll go and substitute, and I'll substitute that one here. So I'll get 1, 0, 0, 0, 0, 4 zeros, 10,000, okay, times 12, then minus what's 10,000. Okay, so indirectly, we are going to get this will be equal to 120,000, okay, minus 10,000. I hope you are following my professors. Okay, which gives us what?
110,000.
Okay, 110,000. However, be careful, because you can see that with this one, you've been asked to find a cost, and the cost came with a unit. Okay, so in your conclusion, you should attach the unit if you cherish what? Okay, your conclusion mark. So at that point, I know that the currency there is what? Cedis. So then I write what? 110, okay, thousand. And if I like, I'll bring 2 dots there. It's my point. I mean, dots then 2 zeros, I should say. Okay, I can equally ignore because the currency itself didn't bring what? The 2, okay, dots, the 2 zeros there. Is my point well made?
Yes, sir.
Okay, very good. So any questions? If no question, I've told you, with this one, we could have started from here straight away. Okay, if you want to do this, meaning this could be done as a rough work. Okay, take notes. All right. Now, okay, Prof. Amma,
Mr. Hackman, please, I want to ask a question.
ask.
Mr. Hackman, please, is there a possibility that the question wouldn't give us values?
Values as in?
Like, do not give us values to be able to find for constants.
No, other than that, if we won't give you the values, then we are supposed to end at the point where your equation will be in terms of your constants. Because you cannot, if I don't give you the value to find your constants that you have introduced, okay, there is no way you'll be able to express one quantity, okay, not involving the constants that you introduced.
But so, sir, when we are answering the questions they bring out, our answers should be in constant form, right?
In what? Did you say constant form?
Yeah, like when we conclude, K will be part of the answer.
Did you say Q?
K, constant.
That will be part of this answer.
No, I'm asking the question I asked, that if they don't give us values and maybe they give questions under that main question, our answer will conclude with a constant, right?
Yes. In that case, okay, I cannot tell you to express C in terms of N. You get it? Because you cannot
Yes.
express C only in terms of N. You will involve your constant. I can say that maybe find an expression for C. So if I ask you to find an expression for C, that could be in terms of the other letters as well. Though usually when you are asked to find, okay, in terms of C, we need to find the letters, the letters that we introduce, which will be our constants or constants. Okay, however, if it is in terms of other variables, then strictly it should be in terms of the other variables.
Yes.
Okay, great. All right. So if you don't have any further questions, then we'll move on to probably maybe our last, okay, questions. And let me see whether it's the last question under yes, then this will be assignment. So I'm right. So one more question under the partial variation. Then after that, we'll go and look at what likely exams question, which will equally bring in partial variation as well. Okay, so if you don't have further questions, let's look at the solution to this particular question, question number 3. Now, let's see. The cost of producing a bottle of cooking oil is partly constant. So you can see the keyword there. So we should know we are dealing with partial what variation. Partly constant and partly varies as the inverse of the number of bottles produced per day. Okay, then the cost of producing 4 bottles per day is, okay, what you have there. And that of 5 bottles per day is exactly what you have there. Find the number of bottles produced per day if the cost is. So you are finding a certain quantity, giving another quantity. Okay, the reason why I picked this question, the more reason why I picked this question, otherwise I know you can deal with this question, is that if you look at this question, do you have any letters introduced? Do you know your variables?
No, please.
No. Okay. So with questions of this nature, we deals with what? Variation. You know that variation usually, though you'll be dealing with quantities, but the quantities must be represented by letters or variables. Okay. So in that case, what do? Any quantity that you don't know its letter is not given, you are supposed to, okay, make that representation. So with this one, you are supposed to start with the representation before you can form your relation using the letters. Is my point well made?
Yes, sir.
Okay, so here let's look at the quantities. So if you read the question carefully, you'll see that one of the quantities will be the cost of producing, okay, a bottle of cooking oil. Am I right? Okay, so I will let, okay, that's my first quantity. Because it's cost, I want to use C, maybe capital C. If you like, you can use small c. But like I said, okay, if you use small c here, your constant, the other constant that you will bring, because you are told that it's partly constant, you use what? Capital, and vice versa. So I'm using capital C here. So the other one, I will use small c. So C will be equal to cost, or the cost of, okay, producing. So you are defining your letters that you are introducing. Okay, a bottle of cooking oil. My professors, I hope you are following.
Yes, sir.
Okay, and you can see that don't come down, you have space, so continue. And your other letter, let's see. Okay, so let's see the other quantity. And partly varies as, okay, the inverse of the number of bottles produced. So you are dealing with another quantity, which will be the number of bottles produced per day. So I will use n, small n for that. So n will be equal to number of bottles produced per day. Is my point well made? Okay, so at this point, now that you know the letters that you are going to use, you can form your variation statement and therefore the relation statement. Okay, so I can say that this implies that now we are told the cost which we have represented by capital C is partly constant. So I will write C varies partly as a constant, small c. Okay, and varies, okay, as the inverse of the number of bottles, which we represented by n. So once it's inverse, it will be 1 over n. Is that clear? Okay, which again will give us, okay, implying that C will be equal to capital C will be equal to K sub 1 plus K sub 2 all over n. Do you agree, my professors? Hello, can you hear me, my professors? Can you hear me?
Yes, sir.
Okay, great. So now if that's the case, then, okay, what do we do? Have I left anything out in my presentation so far?
Yes, sir.
Which is?
Constant.
Very
K1,
good.
K2
Very
equals
good.
constant.
So K sub 1, K sub 2, okay, will be, okay, constant or are constant. So now, okay, we need to, this equation for C is in terms of K and what? K sub 1, K sub 2, and N. Okay, but you cannot predict the value of what? Of C, okay, given N if you don't know K sub 1 and K sub 2. You can equally not predict the value of N given C without knowing K sub 1 and K sub 2. So you need to know the relation for C in terms of N only before you can use it to predict. So now we set out to look for our K sub 1 and K sub 2. The constants will always be, okay, a constant that you are supposed to find. So we are going to find those constants. So if now the first statement here, the cost of producing 4 bottles, so N is equal to 4. Okay, our C will be equal to, the cost is what? 1, okay, 1,600. And I said here, you can ignore the unit and or even ignore the 2 zeros. Okay, all right. It's when you are concluding that usually you bring that. Then, okay, we are going to get, this implies that if N is equal to 4 and C is equal to, get 1600 is equal to what? K sub 1, and K sub 1 we don't know. Okay, then plus K sub 2 equally we don't know, but we know our N is 4. Okay, unfortunately, we can't label our equation at this point, or it is ideal to clear the fraction before labeling the equation. So what do? We are going to, okay, clear the fraction. So each of the 10s multiplied by 4, I'm relying on you. So this times 4 will give us, my professors, are you there?
Yes, please.
So that will give us,
6,500.
okay, so 6, okay, 1,000
6,000.
point, okay, so 6400 is equal to, then you get what? 4K sub 1, okay, plus K sub 2, all correct. So this cannot be reduced. So you label this as your first equation. Then you go to and generate your second equation using the second information. So if N is equal to the second information, okay, if N is equal to 5, okay, C, your capital C is equal to, okay, 1420, 1420. So you go and substitute. So this implies that 1420 will be equal to K sub 1, okay, then plus K sub 2 all over your 5. So we are also going to clear the fraction before we label. So this 1 times 5, I'm relying on you. My professors.
7100.
7100. Okay, so this also cannot be reduced. So you label this one as what? Equation 2. Okay, all right. So at this point, we are going to continue, okay, to better our understanding and indirectly to revise and get the skills in solving equations simultaneously. Okay, so now let's see again. Let's look at this one. Okay, equation 1 and equation 2. If you study them critically, which method of solving equations simultaneously do you think will be ideal? Listen to the 2 equations. What are the equations telling you?
Elimination.
Elimination. So which one will you eliminate?
K sub 2.
K sub 2. Very good. So on that note, because we are going to eliminate K sub 2, our result will be in K sub 1. So we have to look for the equation with the bigger K sub 1 value. And you subtract the other one from it. So this one, the K sub 1 here is 5. The K sub 1 in equation 1 is 4. So it means we have to subtract 1 from 2. All correct. So equation 2 minus, all because we want to avoid dividing by negative, we want to avoid negative. So equation 2 minus equation 1. So that will give us what? Okay, 7100 minus 6400. I'm waiting. Hello, please hurry up. You know, these calculations are for you.
100.
Come again.
700.
Okay, so 700, okay, will be equal to 5k sub 1 minus 4k sub 1, and that will give us k sub 1. K sub 2 minus k sub 2, that will go. That's what your intention. So now, subtracting, you have your k sub 1 straight away. So you go and call this equation 3 because you need k sub 1 to find k sub 2. All correct.
Yes, sir.
Yes.
Come again. Okay, so if you are fine, okay, then that's okay. We can move on. Okay, so now we substitute equation 3 into which one? Which of the equation will be our preferred equation to carry out the substitution?
Equation 1.
Okay, so equation 1, you went for equation 1, and that will be better because that involves smaller value. Always do go for the one that will involve smaller values. Okay, so in that case, we are going to get 6, 4, 0, 0 is equal to k sub 1. It says 4k sub 1. So it will be 4 into k sub 1, which is 700. Okay, then plus k sub 2. Okay, so what would that give us? We are going to get, this implies that, okay, 4, 6, 4, 0, 0 will be equal to, here, I'm waiting, 2800.
2,800.
Okay, so 2800.
Yes.
Okay, then plus k sub 2. Okay, so now let's go and find k sub 2. Okay, we move this one to the side. So I'll write k sub 2 will be equal to, I move this one and subtract. So 6400 minus 2800. Oh, someone should have been done by now.
The 600.
Okay, 600. Okay,
3,600.
600. Okay, so this is what we have. Okay, so now this is, okay, what we are supposed to get for k sub 2. So with this, we know the relation, but we know you are not asked to find the relation directly. Okay, it's a means to an end. So you cannot draw your conclusions. I will just come and write. This implies that my actual C will be equal to, okay, k sub 1, which we got 700. Okay, plus k sub 2, which gave us what? 36000 all over our n. All correct. Okay, so it's now that we are going to find what we were asked directly to find, which is predict, okay, your n given what C. Your n given what C. So we are going to have what if, okay, C is equal to what value is given? 1150. Okay, then we are going to get, this implies that, okay, 1150 will be equal to 700 plus 3600 over n. Do you agree? So again, what do?
Yes.
Declare the fraction. We are looking for n. Okay, someone can say that move this one to the side before you clear the fraction, or you clear the fraction then later move. It will give you the same result. So let's do that, okay, first. Okay, which one do you think would be ideal? Subtract before we clear, or let's clear before we subtract? So let's go the usual route. So let's clear. This one times n will give us 1150n. Is equal to this one times n, 700n. This one times n will give us 3600. Am I right?
Yes.
Okay, so you move this one to the side because this is bigger so that you get positive. So I'm waiting for you to give me the value here, then I'll write. So it will be equal to 3600. This gives us
450.
okay, so 450. Okay, n.
450.
Okay, so you write it again before you divide. N is equal to 360. Okay, and okay, over 450, okay, over 450. Okay, so at this point, let me see. Maybe I'll squeeze it here, but I have a next page. No, I don't. So let me squeeze it here. So n will be equal to
8.
8. Okay. But here, this is where you have to be very careful. This is where you have to be very careful. In maths, okay, you avoid concluding with what you introduce. You can see that you represented your number of bottles produced per day by n. Somebody can use any other letter. Okay, so you are supposed to, okay, go back to your representation and use that one to draw your conclusion. So in that case, okay, this is what your conclusion should be. Therefore, okay, 8 will be equal to number of bottles produced per day. Is that clear?
Yes, please.
Or you can even write number of bottles, or therefore number of bottles is equal to 8. But the reason why, I wrote 8 is equal to this is that if you don't write, okay, the 8 and write equal to, then follow it with the English, Okay, if you write therefore number of bottles, stop where what is important, which is the 8, you didn't write it. So write the 8 first, equal to, then follow it with the English. Is that clear? Okay, so great. So now it means, okay, if you don't have
Yes,
any
please.
questions, if you don't have any questions, okay, we are done with, for now, okay, partial variations. So we are done with partial variations in general. Okay, we are going to, in our next, okay, 1 hour, okay, or so, we'll be looking at how to make use of whatever that we've learned under, okay, variations so far to deal with likely exams questions or past what questions. So at this point, I would want to say a big thank you for making the lesson a success. Okay, so God bless us all.